Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 18, 2026, just 1 week ago. It introduces a training framework that improves a base coding model by over 25% on the SWE bench verified benchmark, simply by using scalable synthetic tasks. The paper is titled Hybrid GEM, Training Coding Agents to Generalize Across Tasks. And as we'll see later, the implications for training versatile agents without complex environments are quite significant. And for those interested in the implementation, the authors have shared their code on GitHub. To understand the strategy, Figure 1 breaks down the anatomy of coding tasks. The charts on the left compare real-world activities, like issue solving, against the new synthetic tasks in Hybrid GEM. You can see they share a very similar distribution of actions, specifically heavily relying on reasoning, repository exploration, and implementation. The right side then quantifies the benefit of this alignment. When agents train on these specific synthetic components, their failure rates drop sharply compared to the baseline SWE GEM. For example, errors due to insufficient exploration decrease by 32%, while reasoning failures fall by 24%. So, while Figure 1 established that exploration is a key shared skill, Table 1 now breaks down exactly how agents explore using Linux commands. The columns on the left display the command usage for the proposed Hybrid GEM training tasks, specifically focusing on tools like grep and find. On the right, we see the corresponding statistics for real-world benchmarks, like SWE bench. The critical takeaway is the strong alignment between the two. For instance, grep is a dominant tool in both the synthetic tasks and the downstream evaluations. This similarity ensures that the navigational habits agents form during training differ little from what they need in actual practice. Alright, following that alignment check, Figure 2 demonstrates the power of scaling this synthetic data. The chart plots the model's resolved rate on SWE bench verified against the training data size, ranging from a mere 250 trajectories up to 4.4 thousand. A clear trend emerges. Performance starts near 17% with the smallest subset, but climbs steadily to over 32% as data volume increases. This consistent gain suggests the synthetic tasks provide a strong signal, and the curve implies that adding even more data could yield further improvements. Well, given that scaling drives performance, Table 3 highlights the practical efficiency that makes this scaling feasible. It contrasts Hybrid GEM with datasets like SWE GEM and SWE Smith. First, look at the number of repositories column. Hybrid GEM spans 762 repos, vastly outstripping the 11 or 28 found in earlier sets. Then, notice the Docker image requirement. While other methods need thousands of images to handle dependencies, Hybrid GEM requires just 2. This simplicity drives the cost down to 0.07 cents per instance, making it over 30 times cheaper than SWE Smith. Okay, proving that these synthetic tasks work individually, Table 5 isolates the impact of training on just 500 examples of each type. The second row shows the standard approach, training on issue solving, which boosts the base model to 10.6% on SWE bench. Surprisingly, the next row reveals that training solely on function localization outperforms that, reaching 12.8%. This suggests that learning to navigate the codebase is often more valuable than seeing full solutions. Finally, the bottom row confirms that combining all 4 synthetic tasks yields the strongest result, pushing the score up to 15%. So, having validated the individual tasks, Table 4 presents the comprehensive results across 3 real-world benchmarks. The bottom section focuses on the larger QN 2.5 Coder 32B model, where the base version starts at just 7% on SWE bench verified. Training on Hybrid GEM alone skyrockets this to 32.4%, a massive 25% gain. Crucially, this result matches or beats SWE Play, a dataset trained specifically on in-domain tasks. Finally, the last row shows that combining Hybrid GEM with SWE Play pushes performance even higher, proving the synthetic skills are complementary. Alright, to understand what drives these gains, Figure 3 breaks down controlled experiments on the training data. First, looking at output format in Panel A, removing the file editing action causes the resolved rate to plummet from 22% to just 2%. This implies the agent must practice the specific mechanics of editing files. Next, Panel B shows that script-level tasks like LCB barely transfer, while repository-level tasks effectively boost performance. Finally, Panel D demonstrates that complexity matters, as training on the longest trajectories yields a 34% resolution rate. Wrapping up, the key takeaway is that effective training does not require complex, executable environments. Instead, focusing on shared skills like repository exploration through scalable synthetic tasks offers a cheaper path to versatile agents. This implies that teaching models how to navigate code is just as critical as teaching them to write it. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.